We're still talking about systems of equations, and today we're going to look at graphing them. We've solved them by elimination and by substitution, but today's all about graphing. And it's probably one of the simplest ways. There's the least amount of algebra calculations in this way. But today we're going to be talking about graphing, and if you look at these two equations that we have down here on the bottom left, they're in slope-intercept form. What we know is y equals mx plus b, where m is your slope and b is your y-intercept. And remember, b is where you begin, and slope is how you move. So we're going to start with the first equation that's on top, and I'm just going to label it 1, and I'm going to graph it in green. And so we're going to go up here. Our y-intercept is 4, so I'll go up to 4. 1, 2, 3, 4. And we're going to be going down 1 and over 1. So our line should be going downhill, or it should be negative. So if we look, and we draw our line. Now I would do this, I would put as many dots on this graph as I possibly could, because when you graph this, you're looking for an intersection point, and you want it to be as clear of an intersection point as possible. So it's important that you have enough points on your graph to make that happen. So let's draw a line here. Okay, and put our arrows on it, make it nice and accurate. Okay, so now we have to graph our second line, and well, let's do that one. Oh, let's do it in orange. So here's our second line. Now this one has a positive slope, and our y-intercept is -3. So we're getting at -3 on the y-axis, and we'll go up 1, 2, 3, 4, and over 1, 2, 3. Now you see, if I had only put 2 points on this graph, my intersection point would not be nearly as clear. But here we can see a definite place where the graph intersects. So, now we have to name our intersection point. Well, if we look at our graph, it is clear that our lines intersect each other right here. And the x-coordinate for that is 3, and the y-coordinate is 1. So your intersection point is 3, 1. This system of equation has one solution, and it is the ordered pair 3, 1. Now, we have several types to talk about here. This particular one is a one solution system. But if you look at this chart, a one solution system, the slopes are different, the y-intercepts can be different or the same, and the lines intersect. That's important to remember. Now, we have some other systems that one will be infinitely many solutions and one will be no solutions. So let's look at those. Here's our next system, and so if we graph those, I'll graph the first one in yellow. These are in slope-intercept form again, just making it simple for you. So this is your y-intercept. It's 1 for this first equation, so go to 1. And now we're going to go down 1, over 1, down 1, over 1. Oh, I'm going the wrong direction. Down 1, over 1, down 1, over 1, down 1, over 1. Okay, and we'll draw our line. And here we have it. Okay, so here's the line for the first one. Now we're going to need to draw the line for the second one. Let's do that one in pink. So here's line number 2. Your y-intercept here is 2, and your slope is the same. So here's my y-intercept. Here's my y-intercept at 2. Now these lines are going to be relatively close together, and our slopes are going in the same direction. Okay. And so as we graph this line, through our points. While these are relatively close together, what we can notice is that these lines, while they're close together, are never actually going to touch. If they never touch, this is what we call, well, we don't have an intersection point, so there are no solutions. There's no solution to this system of equations because there's nowhere that they're going to touch. So if they do not touch, then there will be no solution. Flipping back here and looking at our chart, no solutions mean the slopes are the same. Well, if we flip over, we had a slope of -1 and a slope of -1. Those are definitely the same. The y-intercept is different. Okay, our y-intercepts, yep, they were different. And then our lines are parallel. Well, parallel means that they do not touch. We would hope that the lanes of traffic would be parallel because we don't want to run into one another. Alright, so parallel means we do not touch. And these lines are going to do just that. They're not going to touch. And when you have the same slopes mean parallel. So if you have the same slope, you can automatically know these lines are parallel. So just things to remember. Okay? Alright, we have one more type to look at. Alright. And this first one's in slope-intercept form, so it's pretty simple to graph, and we'll go ahead and do that. We'll graph this one in green. So, graphing this first one in green, your y-intercept is 3, so we go to 3. And then we're going to go up 1 over 2. Up 1 over 2. Up 1 over 2. And we can go backwards. Down 1 over 2. Okay, and that should give us enough points to be able to see what's going on here. So, graphing our line, drawing it through right here. Alright, and I'll just put some arrows on it. Make it nice. Now, this other equation, we're going to need to change around a little bit. So, we have -x plus 2y equals 6. Let's go to a blank page over here. We'll just work it out. So, -x plus 2y equals 6. Okay, so we need to get y by itself. So, working on that, let's add x to both sides. Alright, so once we've added x to both sides, and we can't combine these terms, you have 2y equals x plus 6, and you can rearrange these. I went ahead and did it on my own. Now, remember, this x has a 1 in front of it. If it helps you remember better, go ahead and draw that there. Now we need to divide by 2. Remember, everyone gets a 2. No one needs a 2 left out. So we have y equals 1/2 x plus 3. 1/2 x plus 3. That's the second equation. So we can go over here. Y equals 1/2 x plus 3. It's this one. If you notice, y equals 1/2 x plus 3. Y equals 1/2 x plus 3. So if we were to graph this second equation, number 2, our line would be exactly the same, wouldn't it? So if you draw this line, it being exactly the same, let me get it straight. So you draw this line, it's exactly the same. This means, obviously, it's not no solution because this line is intersecting over and over and over and over and over because it's laying on top of itself. So instead of being no solution, we call this infinitely many solutions. This is infinitely many solutions. Because it's touching itself over and over and over again. It's infinite. It's touching itself infinitely many times. If we go back and we look at our chart that we started with, infinitely many solutions means the slopes are the same, okay? the y-intercepts are the same, and the lines are the same. So looking at our picture, we had our slopes the same. Okay, you look. Here the slopes are the same. Our y-intercepts are the same. And our lines are also the same. That is inflating solutions. So this chart would be helpful to know. One solution, you got different slopes. Your y-intercepts can be the same or different, it doesn't matter, and the lines they intersect once. Inflating solutions, the slopes are the same, the y-intercepts the same, the lines are the same. Everything about everything is the same. It's like you have identical twins. And then no solution, the slopes are the same, the y-intercepts are different, the lines are parallel. Same slopes mean they're parallel when they have different y-intercepts. So these are all important things to remember as you graph systems of equations.